see what's going to be the focus today. What I want to do is, I don't know whether I covered this in the Python course. When you have an n-dimensional array and you have a pattern to initialize it with, you did lots of exercises using different for loops and writing long Python code. Now, why don't we try out something which may be possible for initializing as well as creating some n-dimensional arrays, okay, mentioning the row and column of multiple dimensions, and then fill it also with some values in a shortest possible way. Okay, that is what I am trying to do. And elegant solutions you can develop on it. Okay, once you know what is happening, so you can develop on it. So that's the focus. What I plan to do is, I am going to only show some piece of code. We'll try to execute, understand it, execute it, and then go forward. Okay, this is going to be a purely some interactive programming exercise. Now, okay, to start with, we are going to use both normal Python array, n-dimensional array, and then we will see that it can be used, the same logic can be used for creating a NumPy array also. So I will show you a couple of examples, and then we will not talk about NumPy more often, because I want to tell you the different techniques. Maybe most of them you might have already tried it out or maybe aware, but it will be a good revision even if you are aware of some of them or all of them. Okay. Now, let me start with the first one. So what I am going to do, I have defined two constants. Okay, this is the reference. Let me show you the site. This is, I don't know how to pronounce it. This is a very good, yeah, go ahead.
Sir, is that is not visible.
Oh, is
not
it?
showing the same.
Oh, I'm sorry. I don't know. Every time I do the mistake. Thank you. I think I should present now. I should enable always. Thank you guys. Sorry about it. Okay. Now I think, apart from asking you whether am I audible, I should ask you whether am I visible. Okay. Two questions I have to ask: audio and video. Okay. I hope you can see now. Okay, you can see me also. Okay, now what I was saying. Okay, I'm going to talk about this is what I was showing you, the screen. N-dimensional arrays. We will run one example, and then indexing into NumPy array, a few techniques we will see. Now I was saying that I was showing you this program. I'm going to run it. This is the website. I have referred most of the things, but something I have added to that, and I don't know whether you guys have come across this website. I felt this is very good. Okay, I don't know how to pronounce it. There are many things. If you want to know anything suddenly, if you have a doubt, please refer this. This is very good coverage. I understand. I feel that this website is good. Only thing is, it will ask you for a registration with your email ID, and they don't charge you anything. So we can just access this website, which is very good. Okay, now what I'm going to do today, it's for creating some n-dimensional array with different values initialized. Okay, along with that, now I have two constants, C and R variables, where values 4 and 5. That means 4 columns. I will be using this for the index range generation. Okay, the generator, sequence generator, and then we are going to generate different rows and columns using various values, different values. You know, the common convention of this is comprehension. So what we are trying to do, I want to create an array now. It's a Python array. As actually, it's not even an array, it's a list. Okay, you know that it is a list of list. So even though when you use this list of list into a NP array, it becomes a NumPy array. Otherwise, if you remain in Python world, it will be a list of lists only, which we have done so many things in the last class, last course, Python course. So now I don't know whether I covered these things. Suppose if you have a value you want to generate, can you guess what is going to be the output of this? Okay, C is 4 and it says that I am creating an element filled with the value 0 into 4. That means, is it going to create 4 times this small elements and a list, or is it going to create a list with 4 elements inside? Okay, that is the one thing. Now let us keep that aside. When you have a expression like this, what does the Python interpreter do? It finds out the iterator and generates one value out of whatever it's supposed to be. So range R means it is going to generate from 0 to R minus 1, and for every I value that it gets, it is going to do this. So this part of it is trying to control how many times it is supposed to do this. So I have put R here. That means I am going to create that many rows. So it is going to control that many number of rows are going to be generated. And I have put a C here, which is column number of column entries. So you can guess it that when you do a multiplication here, it is going to create a list with this many number of elements in them. Okay, it's not that it is going to create this list multiple times. It is going to create a list with this many number of entries. Now because it is 0 and C is 4, you are going to get 4 zeros in a list. How many times it is going to do it? Range R is 0 to R minus 1, which is nothing but 5 times. So it is going to generate a row with 4 elements in it, all filled with zeros. And how many rows? 5 rows are going to be generated. So that is how to understand this. So it is going to generate 5 rows with each of them having 4 values in it. Because we are multiplying this, we are saying that I want you to create 4 times this value in the list. So that is what is going to happen. Now we are creating a list of list here. It's not an array as such, but we can use this list of list to create an NP array, which is nothing but you keep it inside. Whatever you do here, you keep it inside a NP array, not NP ones or zeros. It should be NP array, because value is decided here as well as the number of elements and rows are going to be decided by this. So these many, what happens is when you do this, we are passing a list object to the creation, and the list object is created like what is shown here, and then NP array is going to generate an array of that. So this is what will happen. Now maybe we can print it and see whether are we getting exactly. I didn't do that shape. Okay, yes. Okay, so it has created an array of 5 by 4, 5 rows by 4 column. What it has received? It has received a list of list, and when you have a inner list, it is treated like an array element, and then it goes on like this. So you can create a shape, whatever shape you want, using this kind of a comprehension. Okay, I hope this is okay. Now let me take an example, another example. Let me take both NP example as well as the Python example. Now let us see what is happening here. Here also the for loop is first processed, and a value for I is received here. And then here not only that we are going to do this multiple times as per the value given here, or but it is also using the value that is coming out of this, which is inside. So you can guess from instead of this entry, what are you going to create now? Very easy, I'm sure. This will be all zeros. This will be all ones, 2, 3, 4, all fours. So that is what is going to happen. I'm sure you might have guessed it now. So this for loop is controlling how many times this whole thing has to be executed. Apart from that, it is also controlling the value that is going to be there in it. So that is what is going to be the output. So 0, 0, 1, 1, 2, 2, 3, 3, all 4. So if you want to generate such things, maybe earlier we used to put a for loop and then execute it. Here also we are putting for loop, but in a concise comprehension. This is called comprehension way. This is a very concise way of developing it, and the Python developers expect you to use this technique only, not a for loop with a array initialized like what most of the time in the assignment in the Python class we have done. But we should try to do change over to this way of doing wherever you have an opportunity to do. It is not confusing because Python developers understand this, and when you look at somebody's code, Python code, maybe if it's an expert who has written it, you will see that they have written it this way. So try to develop this. If you are not done already, do not use a for loop, but try to use this technique for filling up arrays wherever you are using in NP array or as well as in Python array. So going forward, I'm not going to create a NP array because whatever a normal Python list you create can be used for generating NP array. So I approved it in a couple of examples. So we will not repeat that again. Now, can you guess what is happening? There are two for loop. Okay. Which is the inner loop? Which is the outer loop? Now, look at the interpreter going from left to right. It looks at this for loop and picks one value. Okay. Let me notepad. Where is it? So it is like for loop for I in range R, and then for j in range C. It is similar to this. Maybe, yeah. So it will have one value with I come in and then pick one j for this I, all j's, and then another I with all j's. Okay, that is like a typical outer loop. This is outer loop and this is inner loop. Now, if you want to create a two-dimensional array like this, okay, maybe longer, this is number of columns and this is number of rows. So which one of this should be here, whether you should use R here or C here? So normally when we are creating the element in a two-dimensional array, we fill the column first because this is a row major. Okay, remember Python and NumPy, everything is using row major because not that they love row major over column major, because NumPy itself is implemented using C and C follows row major. That is the reason Python NumPy follows row major. Now, if you are doing a row major, that means you need to fill the columns first. So column entry has to be the inner loop and the row entry has to be the outer loop, so that you can finish one row at a time and fill all the column elements. So what we want to do here, I am here. Okay, this is a row, one element I is chosen and then all j values are taken one by one and it is going to fill it. Now, is it going to create a similar array or not? Is it going to create a similar array or not? Though I say row and column, it is not going to generate an element like this, because we are using the I and j value internally and then creating one list object for every for and outer and inner iteration. We are creating one list object. So what is it going to be? It is going to be row into column number of individual lists. In NumPy, it will be individual arrays element. Okay. So what is happening is, because we have put I into j inside and then creating a list object here, I'm sorry, we are not doing what we did here, but it's also one way of understanding what is happening. So how many zeros are going to be there? Now let us see. 4 are there. That means, let me run one by one. I is equal to 0 and j is 0, 1, 2, 3. Because C is, how many, what is C? C is 4. So j is going to be from 0 to 3, 0, 1, 2, 3, 4 element with a 0 value as I. So you get 4 zeros here. Next one is I is 1. I is 1 and j is going to vary from 0 to 3. So 1 into this, and then again I is 2 now. So you are going to have 2 into that, and then 3 into 0 to 3 and 4 into 0 to 3. So you are going to, that's why from this you can make out that out of this for loop, which is running, which is the outer loop, which is inner loop. So this value, what you get is, first this is getting one value first, and then the next multiple values of j is taken with single value of I, and then this is filled. This is how the sequence happens. Okay, if you once you understand this particular sequence, you can guess any other combination that I give you. So let us see now one more. What is happening? This is also same, like for loop is here, another j is here. I have not changed the c and r, so you can guess that how many times this is going to run. But a small change I have done here. It's not a small change, it's a major change. When you put the multiplication outside of this list, it is going to create that many elements, but the j value is not fixed. It is changing from 0 to 3. So you are going to create different number of elements on every iteration, because this is going to change on every iteration. J is going to change on every iteration because this is the innermost for loop, and I is going to be chosen by this. So it will be having zeros first, then ones and all twos and all threes. But how many elements are going to be there is decided by j. So this is also not like you are not going to get an array like this. You are going to create like this. Now look at this element. This is an empty list. Why is it empty? Because j is taking a value which is 0 and it kills this creation itself. So there is an empty list because it is not even creating one element there. It's an empty list, null list. And then with one element, a null list means there is no element. Okay, it is creating a list but with no element, and it creates with one element, two element, three element. Okay, I'm not even say, I should not say that it is not creating a list object, but it is creating a list object with no element. Because j says 0, this list object should not have any element at all. So first one is a null list with no element in it, and then with one element because j says 1, 2, 3. So you get a set of this on one iteration of j, and then with the next value with I of 1 you get the next one. Because I is kept inside, it is going to have all ones. You are going to create like this. Okay, some funny array. I don't know where you will be useful, but at least you should know, if I do this, this is what I am likely to get. So this is not to tell you that this is useful in some time, maybe, I don't know, but in case if you need to do such things, you will get an idea that okay, I can do this way. I hope this is clear. Let me see if there anything happening on the other side. Okay, slide is visible now. Fine. Okay, now let me take another example. I hope I'm not taking the same one. Okay, guys. Now what is it doing? I'm doing now. You have to be little careful. You see that C and R are interchanged now. I'm not saying R first and C next. I'm saying C first, then R next. Why? The reason is this C is used, or even this generation is used inside a list object. It is similar to the precedence phenomena in a when a parenthesis come. When there is a parenthesis, you know that that is going to be evaluated first, right? Or next, whatever its sequence. In this case, it is actually going to be delayed because it is within the parenthesis. Even though left to right, when it is scanning, Python interpreter is scanning, it sees that this is within the parenthesis. That means it is supposed to create a list object. Now, how many such objects I need to create, that information is stored here. That is decided by the row. So the interpreter is running this first for loop to decide on how many list object it is supposed to generate, and then it comes inside to see what value should I fill it with. Once I create a list object, what should I fill it with? For that, this for loop is going to be executed. So what is going to happen? It will pick one value from here, range R, which is 0, comes inside with the value of I. It carries a value of I inside, and then it is going to run this loop C times 0, 1, 2, 3, and then since it is within this iterator is within this list object itself, it is going to use this iterator to fill the values. So initially I is coming with 0, so all zeros will be there irrespective of whatever j is generated. But next time j is going to come with 1 here, so it is going to have 0, 1, 2, 3. Then I is going to come with 2, so it is going to multiply it with 2. So 0, 2, 6, 8. So it is going to have 4 elements which is decided by the column, and number of this such list objects are going to be R times, that means 5 times. So rows are decided by this guy, and the number of elements inside this is nothing but a column, so it is decided by C. That's why C is here and R is here. Okay, whereas here it is in the reverse direction, because the sequence is first this for loop, it is picking up one row and then trying to fill up the values for that row with a C. Because the for loop is executed in this sequence, we have put R and C in this way, whereas here the for loop, this for loop is executed first, so we need to put R here, and then this for loop is coming inside this to know what should I fill that list object with. So column is running second time for every row element. So the RC has to be swapped. So this understanding you should have. Now 0, 0 or 0, 1, 2, 3, 0, 2, 4, 6, this is what will happen. So if you want to generate some sequence of numbers with some offset, you can use this technique, but understand what is happening so that you can play around with it based on what you need. Now let me show you a little different example. Now what is it happening? This is also, it is within the list element, list object. So C is inside, and R is going to come with every value 0 to 0 to 4, and we are now going to generate a value which is in the increasing order because we are going to add it. Now I is going to come with 0, so 0, 1, 2, 3 will be the first row. Second row will be, because I is with 1, it will be multiplied with 1 all the j values, sorry, not multiply, added with that. So you will get an offset of 1 with that. So 1 2 3 4, it will be 2 3 4 5. So it is little, still not a sequence of numbers. It is going to be 0 1 2 3 1 2 3 4 2 3 4 5 3 4 5 6. It's not still a consecutive number 0 1 2 3 4 5 6 6 7 8, not that. It is still, we have not come to that yet. Using the same technique we can generate that, but we have not come to that yet. We are generating using just one offset we are getting and then adding that offset. So we are creating a 4 element with the sequences of 4 offset by one element. Okay, I hope this is clear. Now let me show you something else. What is it happening here? Now again, row is outside. It comes with 0 to 3 values. Now see the fun. I am using C here, the constant, which is the number of column element, which is actually C is 5 because 4 columns are there, so C is 5. Now can you guess what is going to be the value? Because I is going to come with 0, 0 plus you are multiplying with all zeros here, so this is not going to have any impact. So you are going to get 0 1 2 3, but next time it is going to come with 1, so it is going to add an offset of 5. So after 0 1 2 3, C is 5 or 4, yeah, 4. So 4 5 6, and then it is going to add 2 into that, so it is going to give that offset. Now you can guess what is going to be the output. I hope you have done. This is the output. Now why is it a fixed value? Because we are adding I only. It's not, we are not adding any j here. Okay, we are adding I only. So it's not going to be sequence yet, because 0 is added or 1 is added or 2 is added with the multiplied value. So very simple. I am sure you will be, even if you have made, maybe you might have made a mistake that it is j but it is I, so it is not increasing. We are using this j here only to iterate 4 times. We want to generate this 4 times, which is happening here. So j is playing a role, but it is not having an influence on the element value. J is only playing a role of how many elements you want to put it inside the list object, but it doesn't influence the content of that particular element. That's because I is used. J is not used anywhere. But is it wrong? No. You can do it. You can even decide not to use I. You can fill it with zeros. That's, I think I did somewhere. No, I didn't do. I can. I did that. In fact, I can do anywhere. I can fill it with all zeros with using I and j only for number of rows and columns. So that is also allowed. It's not that it will say that it's not used, or warning also will not come, because your intent is to iterate over that many number of times. It is your decision whether to use that value internally to generate the element value or not. So you can decide not to, and it is not going to give you a warning because it is proper. It is a valid Python code. So it doesn't give you warning saying that you are not use the value of j, because you are using it indirectly, that it decides the number of iterations. So it still has a impact on the output. So it will not generate any error. Now is what you might see now. Here I am using the j here, which is increasing numbers, and this is going to be fixed value. Fixed offset is added to the sequence of 0 to 3. Now you can guess that the sequence what we finally wanted is going to be generated. 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So this is the syntax or a equation, small thing, to generate a sequence of numbers filled with arrays. I'm sure you guys did lots of this kind of assignment in the last course, we could have generated with single line instead of for loop and so many iterations and then doing for a loop. All that maybe for a entry level is okay, but now you are professional, so try to use maximum possible this technique so that it is compact, crisp. Always Python language itself is designed for crisp, a short code. Okay, in C, if you try to write a short cryptic code, it will actually be difficult to understand. That's a cost you have to pay for writing a cryptic C code, because it will be very difficult to understand. People will say that do not do that because you will not get a performance benefit by doing it. But in Python, they say try to write such a code, because once you know what is happening, a typical professional Python programmer will be able to understand this better than a for loop. And when you compress it like this in a single line, the mistakes that you are likely to make is going to be less. So you are encouraged and required to write code only like this. Okay, so it is not.
Hello,
Yeah, go ahead.
sir. Sir, here J, sir, be on that slide. Here J into J plus C into Y is basically a number. So what we have to what do we have to do to create a tuple having only one value?
Mm, okay, let me
That,
try 1 second. What do you want to develop? Okay, you are again interested in like this, right? Number of rows, column. In each of them, what do you want?
sir, can you remove this one? Your writing pad.
Oh, sorry. Okay.
Go little up. Yeah, is it what we are doing is we are doing 0000 in AR3A.
Okay.
So that is a list containing a single element.
Yeah.
So my question is, what do we have to do to create a tuple having single element?
Oh, okay. Similar to that, you want to create a tuple. Wait a minute. Let me think. It's a good
So
question.
without using tuple function, TUPL.
Oh, okay. What is AR3A? This is AR3A, right? So let me guess it, okay? Copy. Got it?
Yes, sir. What I was saying is whether you will write comma or not.
Ah, okay.
Without comma, that will be a single element.
Yes, you are right. So you have to write a tuple, sorry, you have to put a comma to inform the interpreter that I am interested in creating a tuple object here for every iteration, not a value of just I into j. So you need to put a comma here, because that's what it is also doing here. If you do that, it will create you a tuple. Very good question. Yeah, thanks. Okay.
Sir,
Yeah, go ahead.
sir, while writing tuple, like here we are writing a single number and then we are putting a tuple. We are putting a comma. So
Yeah.
if we write, suppose 1, 2,
Ah.
comma, just comma. So
Oh,
will there be 3 elements or 2 elements?
okay. Okay, got it. I guess it is going to be two element. Let me tell you why it is. Now suppose I plus j, comma. Okay, so it is not going to be 3 element because it doesn't know what to fill it with. Okay, the third element you are not giving the value. But suppose if you want a third element, suppose let me write I minus j, you should not stop it with this. I think whether you write a comma after this or not, I feel it is going to generate a 3 element because you have already indicated that it is a tuple object. So it doesn't need another comma here. That's my guess. Okay, based on the language definition. Okay, let us see what is it going to do. Yes, my guess is right. Okay, these are all you can actually make a guess. Okay, how the interpreter is going to understand. Okay, it wants to have a unambiguous intent of the programmer. The interpreter is expecting that only. So once I put one element, because I am putting one element, I need to put a comma followed with that, because there is an ambiguity that it could be a tuple object with one element, or it could be just a single element where you are parenthesized. It is not a tuple parenthesis, it's just a simple parenthesis. So whether you are interested in creating a one tuple object with one element or individual entity integer object, it doesn't know. So you need to put a extra comma only for one element tuple, whereas if you are having either 2 or 3, you don't need additional thing. It is not only for this 3 element, even for 2 element I can stop without a bracket. It will accept and create a 2 element tuple. Okay, so you can think.
Understood.
Yeah, okay, you can see that what does the interpreter know or do based on what you give. Okay, fine. I don't know whether array 7 is copied. Array 7 is copied, and it is also run it. So I think I already explained, I think. Okay, so you are having here, you might have confused this fellow if you have put a comma here, because you are not saying it's an individual integer object. So now what will happen? Suppose, can you guess what will happen if I do a comma here? Suppose I put one more parenthesis. I'm sorry. Okay, one more parenthesis I put. Okay, that to say that it is an element, and then I put a comma. What will happen? Individually, these values should become a single element tuples inside a list. Okay, I will remove it after running it. Yeah, that's what will happen. So you have to understand how the interpreter is behaving. In this case, I put this bracket to say, okay, just to tell you that this is an element altogether, this one element, which is a tuple element. Okay, this bracket says that it's a tuple element with a single value. That's why I put a comma here. So it is going to generate like this. Now suppose if I don't put a comma, I put n number of parentheses, it doesn't do anything other than creating a sequence of numbers, because it will ignore all of them, thinking that okay, you are too cautious, you have put too many, you are feeling so cold and you have put so much of sweater on top of your dress. It will assume. Okay, it doesn't assume that you are having something intent. I hope this is clear. Okay, so this is what we got. Now you guys know how to generate things. Now let us come to NP array, our focus of discussion. Where are we at in terms of time? Okay, we are not bad. Okay, now same thing I can do with NP array. Now what am I doing? 1D array. What do I say 1D array? Because this is whatever is going to be in the list is passed as a single list with a number of elements in it. So this 4 actually says how many column elements or how many elements in the one dimensional array. So it is going to be a sequence of number 0 to 3. So 0, 1, 2, 3. Fine. This is very, very straightforward. No issues. Now let us come to a 2D array of using this logic, same logic. Now you have to be little careful. This is one list, okay, and then this for loop is lying outside this guy, okay, this guy. That means this for loop decides how many such list objects I should create. Then you can guess now that this fellow is the row element, okay, it is deciding the row. So I have put a 5 here and j here. Please pardon me, I should have put a r here, no problem. Okay, let me not, why don't I put it, okay, r is 5, right? R is 5 and C is 4, so nothing wrong. So let me not confuse you. So this is a row, it is deciding how many iterations or how many times I should create the list object. So it is going to run this first, come with one value inside, but I am not using the j here, so it is not going to have any influence of j. Sorry, the values in this list are not going to be influenced by the value of j, but the j is deciding how many times this list object is to be created. Now, who is deciding the element values? The I only, and I is going to run from 0 to whatever column times, so it is going to be a sequence of 0 to something. So every row is going to have the same 0 to 3 5 times, okay, that's what is going to be the two-dimensional array that we get, 0 to 3 5 times. I think now by now, once I give you the code, you can guess what is the output, okay, you might have guessed, you might have gained that expertise by now. Now let me give a chance to you to make a guess, not a guess, just to be sure what is going to be coming. I am not going to talk anything. So j is having an influence on the value. I is going to change from 0 to 3. So j is going to be 1 inside. I think this similar thing we saw earlier, so I'm sure this offset with 1, okay, I'm sure you might have guessed it now. Let me show you. I think more or less, I think most of the things we would have seen it already. This is a little different, okay, maybe you can I'm sure you might have got it. So it is very clear, j is coming in from outside. That means it is going to have constant value for all this column. So you are going to have a row with same values, all filled with zeros, ones and twos and threes. So zeros, I'm sure you got it. Now finally, what you are looking for, a three-dimensional array. Suppose I want to generate a three-dimensional array, you can extend it to anything later on. 2 rows, 3 columns, 4 times. Okay, this is how you should read. So 2 rows, 3 columns, each of those rows having 3 columns, that is repeated 4 times, right? This particular 2 by 3 matrix. Now, how am I generating with one single very cryptic line? See here, y is 3. It is deciding number of elements. So into this 0, I am going to create that many number of elements, columns, and how many rows I am going to do, because x is deciding that x is the row, so it is iterating over, this is going to generate that many rows. Okay, then where is this z coming? Did I do z? I'm not having z here. Then where did I write z? Okay, let me run it. Anybody?
Hello.
Yeah.
So Z must come after range. Yeah, from there,
Oh, that code is
and then you
missing.
have to. Yeah.
Where is it? I didn't copy or
So
what?
you didn't copy the second line in the previous line.
Okay. But how is it running? How is it running then?
So please scroll down. You'll find that Z.
Oh, that's what I was wondering. Otherwise, it should not run. And it is given output also properly. Okay. I thought some magic. Okay, no magic. Okay, let us try now. This is the overall list. Inside that, this guy is coming from outside, which is controlling how many times I want this particular 3 by 4 to be generated. So Z is deciding, the Z value is deciding how many times I should I do this, and internally I do a R3, row and column, and the number of column elements are decided by this guy, and the number of rows are decided by this. I am saying this row and column. So you get a 3-dimensional array. Now this can be extended to any level. Okay. Try to do some of the examples that we tried in the last class for broadcasting. If you can use that to multiple arrays, 4D, 3D, then you have to again put one more parenthesis around it and then bring out the last dimension out. Okay, for loop. So that way you can keep expanding it, and with a single line of code, Python code, you can generate any dimensional, n-dimensional array. Okay, I hope this is all clear. Now, do I have time? Should I do that? Okay, I will show you the code of other one. 5 minutes, it shouldn't take much time. So I will try it here only. It's only this much. Okay, because most of the things we have already tried. So you guys will be able to easily make out what is happening here. That's why it should not take 5 minutes. It will not be more than that. Okay, I am doing NP array. Remember, whenever we are generating something inside for the values, when the values are decided by some code inside, you put array here. When you put ones and zeros here, this inside this equation only decides the number of element. The values are decided by the outside guy. So as far as the NPI is concerned, okay, NumPy. Now that means we are generating using this, generating different values. Now what is this? For loop is there. Very simple. Instead of range, I have put a range. Now let me tell you what is the difference between using range and a range. It's only implementation. Okay, I could have used range also. It would have behaved the same way, but for 10 it may not make a difference. But if I have a huge value, 10,000, 100,000 something, then it makes sense to use a range than the range, because range is a Python implementation and it is going to run on the interpreter, in the PVM, and it's not performance wise, it is not efficient. Whereas a range is implemented in NumPy library in C code, even this generation is going to be faster if you use NP a range. So use where you have huge arrays, or make it a habit. If you are in NumPy, use NumPy instead of range. A range is always good replacement. Okay, so this is very clear. I'm sure I don't need to explain that. I am giving some offset and then generated num value is filled into the array. This is little different. I have not shown you. This is, what is it doing? I am having an NP array and then it is similar to slicing. Okay, already NP array is created and then I am indexing into that array and finding the values which are more than 15, I am picking it up and then creating an array. Okay. See, what is happening is this NP array is already initialized with this value. If it is going to, is actually NP array is behaving like a generator. Okay. It's nothing but it is generating few values based on number of elements in it. It is going to offer that value to this check, and it is going to generate a value between, okay, if I run it, you will know that it is between 10, 11, 12, 13, 14, 15. So every value from this array is picked up compared with 0 greater than 15. If it is true, that value is put into this new array. Maybe I should have, maybe to avoid confusion, I will create a new array so that you don't think that it is working on the same array. Okay. What is the error? Oh, doesn't allow. Okay, I can do this only within this. Okay, I think I tried it earlier and I forgot. See, you can do it on the same array only, but it is picking up whichever is greater. It is creating a new list and forming a new list vals here. Okay, and then outputting it. So let me run it so that you understand what is happening. It has created a list of elements which are, no, sorry, where is it? Here, list of elements which are more than 50. Okay, so 16, 17, 18, a subset is, it's like a slicing in a different way. Okay, I am explaining the slicing here. Maybe I should indexing and slicing of NumPy array. We learned some slicing earlier in the Python course. So you know that when you have dot dot, that means all the elements with the offset of 2. So it is going to run through the element and pick up indices which are starting from the start index, end index, and then offset of 2. So it is going to pick up alternate elements from the list. Is it alternate element or no? Oh, I am doing it from vals. Okay. No. Sorry. What is happening? Why is it 10 to, okay, it is starting from 10 only. Yeah. So alternating elements, it is picking up and putting it. Okay. I hope this is clear. And then if you are generating an NP array, you also have a option to say what type of element you want. Default, it generates integer because A range is generating an integer sequence. You can also say float. Then the type what is generated is of float type. Okay, same thing with the float type. And this I leave it to you as a homework because this already I have explained in the n dimensional thing. I don't need to explain. I am sure if you try to understand it yourself, actually it will be better than me explaining. I am going to call this as a homework to make you understand. Homework understand all the generator arrays below. Okay, because whatever I explained is logical here. Okay, please go ahead. Any questions? Yeah.
Sir, can you scroll little? The comparison one.
Yeah. This one. Okay.
Yeah, sir. The reason why we are using NPAR1 is because of the size issues. The size may not be the same. That's why we are using. But we can also use np.array and do this.
Are you?
So what I'm saying is,
Okay. One second. I got what you are saying. Maybe that's why it didn't allow, you are saying. Okay. But
yes, because of the size issue.
Oh. Are you sure? Okay, let me try.
np.array.
You have to put a bracket. Okay. Am I printing it? Okay. Okay, I am printing this only.
So inner bracket, the square parenthesis is also not required.
Is it? Okay. No. See what is okay. Let us see what is happening. This vals is okay. Let us copy this vals and that val because we'll have confusion. Okay, vals new. Uh, okay, let us run it once for all and then understand what is happening. Good point. I have not tried it out, so we can try. Okay, tell me now what is happening. Vals, where is vals?
Sir, it is just comparing each value with 15 and outputting the truth value. If it
Yeah,
is greater than 15, it's true. Otherwise,
yeah. So it is creating an array of element. Okay, it is. But why should it? Oh, it is comparing all the elements. Okay. So as I mentioned earlier, that NP array is like an iterator which is giving value every time. Okay, every element of that array is given out, and it is compared with 15. And what is the true value? Truth value is passed on. So you will have the same number of element as in the original list. Now here, why is it having a subset? That is because it is doing the comparison with the value of.
Sir, hello?
Yeah, go ahead.
Sir, can you try one more thing?
Yeah,
Can because what we can see is basically this AR greater than 15 is basically a returning an list of true or false. So AR NPAR is taking a list of Boolean values. So
correct.
so if we instead put this vals new, if we put vals new inside NPAR1, we should get the same answer.
Correct. You are right. Okay, let us do that. Vals. What do I write? New. Oh, okay. I got what you are saying. Okay. Uh, okay. Okay. So we got it back. So what is it doing? Now from this we can understand what is happening here. So this guy returned a true or false list. Okay, it's really created a list. As many number of elements are there, it has created a true or false list. And then now we have got a new thing that this, if you pass, yeah, I think we can do a for loop also to generate some true false element to selectively pick up some values from the original list, original array. Isn't it
Hello?
right? Yeah.
So I have found one more thing. np.array is also not required. We can remove np.array and simply do npar1 greater than 15. It will also return the boolean value of same size.
I didn't get you.
So on line number 15, just
What?
remove np. Line number 21, sir.
Okay.
Wait. Line number 21, remove np array and keep the inside material same and greater than the comparison.
Oh, sorry.
Yeah, this also returns the same boolean array.
That is true, but NP array will generate the object of true values. Okay, that is true. It will generate the true false. Okay, where are we? Did I print? Where did I print? Get values in NP array. So this is, yeah, that is true because it is. Oh, this itself is generating a. This is very funny, right? is not very obvious. From this code, you will not know that it is going to generate a list of trues and false. So effectively what is happening is, if you are doing any operation with a NumPy array, it is going to be a sequence, looks like. Okay, we have to try out many things.
Sir, the reason that I this clicked was because in the morning I was doing some image processing stuff, and if you do the negation of it, it does the bitwise thing and returns the array of the element-wise operations, and returns the array of the list of the same size of the same type.
Okay, I think NP array has any operation on NP array, it goes into an element wise. So that's why I think here what you see here, that into what when I put okay, that is a list actually. That is nothing to do with that. So NP array is little.
Sir, this is also, this should be obvious because isn't it like broadcasting thing? Because if we multiply a NumPy array with 3, it applies to everything.
Correct.
Each and every element. So
yes,
this should also apply.
Yes, you are right. Okay, where are we? You are here, right? Even this greater than 15 is like a broadcasting. Okay, even the performing this greater than 15 is like a broadcasting that we want to do on every element. So it's an operation, scalar operation. Okay, so you are right. This is nothing but a demonstration of. This is nothing but a demonstration of broadcasting in NumPy. Okay. So this is an operation. Nothing is no. I was thinking that it's only limited to numerical operations. It includes logical operations also, and this is a scalar value. So it's applies on all the elements of the array, and then it sends it to everything, and then gets you back the same number of elements that you were originally. So that's why you are getting the same dimension of values null. Vals null new will also be a NumPy array. It will also have the same shape as. Okay, let me write the shape of, because it's a scalar operation. Where is it? Yes. Very good. So thanks Sandeep. We found something like even the logical operations happen on the NP array as a broadcasting feature. Very good.